All right, we have a quiz next class on this first derivative stuff. The big idea here is that if we have a function f, who knows what it looks like, something like this, we can tell a lot about it from its derivative. And in fact, using the derivative helps us analyze it very easily. Some things we should know. When a function is increasing, the slope of the tangent line is positive. And so what that means is the derivative has positive values. Even if there were negative f values, the slopes are positive, and so the f prime values are positive. This is f prime. If the function is decreasing, we know that the function has negative f prime values. Even though the f values, the y values are positive, the slopes are negative. And then later on we see that the function has positive slopes again. And this is helpful because this is a local maximum point, and the slope of the tangent line there is 0. And the way we tell it's a local maximum is that the derivative changed from positive to negative. The slope of the tangent line went from positive to negative because f changed from increasing to decreasing. And so we'll see the derivative cross from being positive to negative because that's saying the slopes of the tangent lines change from positive to negative. Similarly, when there's a minimum value, the tangent line is 0, the slope of the tangent line is 0, and the slopes changed from being negative to positive. So f prime changed from being negative to positive. There's a new thing, which is that if we have f on a closed interval, the only possible places there could be an absolute maximum or minimum are the local maximums and minimums, which is where f prime is equal to 0. But also, there could be a maximum value on the endpoint or a minimum value on the endpoint. Here we see that the maximum value would be like right here, but the absolute minimum value is right here. That's lower than this other point. And so let's see how we do that in some problems. This first problem, the calculus is pretty easy. The actual annoying part is the arithmetic, the middle school math. So we see there's this function, and the domain exists from 0 to 9. So this function is only defined between x is 0 and x is 9. After that, it's cut off. The absolute it's the absolute maximum value of the function. Absolute maximum value will be the highest point. This is some cubic. Maybe it looks like this. I don't know. Maybe the maximum happens here. Maybe the maximum happens here. Maybe it doesn't look anything like this at all. I don't know. Occurs when x is what? So we want to find where the absolute maximum happens. So the possibilities are the critical values, and that's where f prime equals 0. So f prime of x is equal to, this is the power rule, so f prime equals x squared, 3 times 1/3 is 1, minus 8x plus 12, the derivative of negative 5 is 0. And we want to know where that's equal to 0. Well, this can be factored, x minus 6 times x minus 2. Where does that equal 0? X equals 6 and x equals 2 are the critical points. Now, this could be the maximum and minimum, or 0 and 9 could be the maximum and minimum. Here we do what's called the candidates test. We don't use the derivative anymore. We literally just look at the function and see what are the y values at each of these points. And so we're going to find what is f of 0, what is f of 2, what is f of 6, and what is f of 9. Those are the only places there could be a maximum or minimum. F of 0, f of 2, f of 6, and f of 9. So f of 0, we're going to plug in 0. That one's easy. It's negative 5. 0 plus 0 plus 0 minus 5 is negative 5. And then they get annoying. F of 2 is equal to 2 cubed is 8. 8 times 1/3 is 8/3. 2 squared is 4. Negative 4 times 4 is negative 16. 12 times 2 is 24 minus 5. So 24 minus 5 is 19. 19 minus 16 is 3. And so this is 3 plus 8/3. I'm going to come back to this one later if I need to. It's a smallish number. But this might be the maximum. It's bigger than this one. I need to find f of 6. And this is where it gets annoying. I could do 6 times 6 times 6 and divide it by 3, or I could do 1/3 So I could do 6 times 6 times 6, or I could do 1/3 times one of those 6's and then finish multiplying. I'm going to do that. It's easier, smaller numbers. 1/3 of 6 is 2. 2 times 6 is 12. 12 times 6 is 72. Here we've got 6 times 6 is 36. 4 times 36 is 144. 12 times 6 is 72. Minus 5. 72 plus 72 is 144. Minus 144 is 0. Minus 5 is negative 5. So already we know these two won't be the maximum values because they're less than this positive number. The last one is f of 9. Geez, I don't want to do this. 9 times 9 times 9, or I could do 1/3 times 9 times 9 times 9 and do 1/3 of 9 first. 1/3 of 9 is 3. 9 times 9 is 81. 3 times 81 is 243. We also need to do 4 times 9 squared, so 4 times 81 is 324. I have a really hard time doing arithmetic when I'm talking. Maybe I'm going to get this wrong. I don't know. Plus 108. 9 times 12 is 108. Minus 5. And let's see. 243 plus 108 is 351. Minus 324 minus 5. So this is, let's see, 27 minus 5 is 22. All right, so is this the absolute maximum or this the absolute maximum? Well, 22 is bigger than whatever this is, 5 2/3. So the absolute maximum value occurs when x is 9. That's what it asked, was where does it occur when x is 9. If they had asked what is the absolute maximum value, that answer would be 22. But because they asked where it occurs when x is whatever, the answer is 9. So you should be able to tell the difference between, are they asking for the maximum value, which is 22, or where it occurs. The rest of these questions really are ones we've already done from the previous homework, but I'm going to go over number 8 because it has a tricky algebra component to it. How many critical points does the function f of x equals this have? So the first thing you should do is be translating this. So how do you find how many critical points? What are critical points? Well, the critical points of f of x are when f prime equals 0 or is undefined. And we don't have f prime, so we need to find it. So the first thing I'm going to do is I'm going to find f prime of x. And when I do that, I notice I have to take the derivative, and this is a product. This is the product of two things. This is x plus 2 to the 5th times x minus 3 to the 4th. You should recognize immediately that it's two big things multiplying together. And the product rule says we do the derivative of the first one times the second, plus we leave the first one alone times the derivative of the second one. You should be an expert at the product rule at this point. When we do the derivative of the first one for the first part of the product rule, the derivative, this is a chain rule. It's something to the 5th power. So the derivative of something to the 5th power is 5 times that something to the 4th power times the derivative of that something. The derivative of x is 1, and the derivative of 2 is 0, so it's just times 1, which I'm not going to write because multiplying by 1 doesn't do anything. So whenever you have the derivative of x plus something or x minus something, and the derivative is just 1, the chain rule isn't going to do that much for you. Okay, so it's the derivative of the first. We did the derivative of this times, we leave the second one alone, plus we leave the first one alone, times the derivative of the second one. Again, this is a chain rule. Something to the 4th power, the derivative of something to the 4th power is 4 times that something to the 3rd power times the derivative of the inside function, which is, again, just 1. And so critical points are, again, we're looking for how many critical points that has. This is, where is this equal to 0? And it's never going to be undefined. This is just polynomials. There's no place where we're dividing by 0 or taking the square root of a negative. So we need to do some algebra here. How do we find where this is equal to 0? Well, we might just look at it and say, hey, you know what? At -2, both of these will be 0, and 0 times anything is 0. And at x equals 3, both of these will be 0. But that's not very good algebra, and we would be missing an answer. When we have a polynomial, we want to factor it. And we could multiply all of this out and try to factor it, but oh my god, that would be terrible. You would be doing long division forever. Instead, we can notice that there's a common factor. Both of these have a lot of x plus 2's, and they also have a lot of x minus 3's. They both at least have 4 x plus 2's. This means x plus 2 times x plus 2 times x plus 2 times x plus 2. This one has even more x plus 2's. I'm going to rewrite this as the common factor is they both have x plus 2, and they at least have it 4 times. This one has it 4 times. This one is x plus 2 to the 4th power times an extra x plus 2. That's what x plus 2 to the 5th power is. Okay. They both also have x minus 3's. And the common factor is that they both have x minus 3 at least to the 3rd power. And this one will have an extra x minus 3. This is x minus 3 times an extra x minus 3 to the 3rd power. This would be x minus 3 to the 4th power, but the common factor is that they both have x minus 3 to the 3rd power. So when we factor out a common factor, we say what's left over. So this will multiply times the first one to get us this one, and what's left over is the 5. We already are multiplying times all the x plus 2's, but we need an extra x minus 3 here. That way when we multiply, we'll get x minus 3 to the 4th power. Here, when we multiply times the second term, we'll need a plus here. I'm going to move this 4 to the front. The 4 is still left over. We factored out x plus 2 to the 4th, but we need another x plus 2. And we've already factored out the x minus 3 cubes. And we can simplify this. 5 times x minus 3 is 5x minus 15. 4 times x plus 2 is 4x plus 8. And so this whole thing can be rewritten as x plus 2 to the 4th times x minus 3 to the 3rd times 5x plus 4x is 9x minus 7. And so where is this equal to 0? Well, it's equal to 0 when x is negative 2, when x is 3, and when x is 7/9. So let's reread the question. How many critical points does f of x have? F of x has 3 critical points. That's the first part. And are all of these local minima or maxima? Well, we could make a sign chart. I could check and see whether they're a minimum, maximum, whatever, and I could put, let's see, negative 2 on here. I could put 7/9, and I could put 3. But there's a slightly shortcut way to do it, which is to recognize, based on the graph, that whenever there's an even power, at negative 2, it won't change sign. It'll just kind of bounce off the graph at x equals negative 2. And so there won't be a minimum or a maximum value because f prime will never change from positive to negative. But at the other ones, it will pass through, and so we'll have a minimum and a maximum there. So these two have minimum and maximum values because f prime changes signs. But if you can do it by using the sign chart and plugging in values, you'll see that this will not change sign. Okay. Are there anything else we need to do here? Yeah, real quick. I think I have about a minute before this video runs out of room. Let's look at number 12. You need to read this very carefully. And it says, the derivative of this attains its maximum. So it says to read this very carefully. I hope you did. By the way, you shouldn't be getting video help until you've tried things very much yourself and you've run into trouble. If you go straight to watching videos, you are doing a bad job on your homework and you will not do as well as you should on your tests. And if you've been getting low test grades and you've been doing that could be a reason why. The derivative attains its maximum value. So we're looking for where the derivative has a maximum value, not where f has a maximum value. The first thing is we're going to find the derivative. We don't need to use the quotient rule here. This is the same as 1/3 times x to the 4th. It's multiplying by 1/3. If the x to the 4th had been on the bottom, we would need to use it, but here we don't. This is 4/3 x to the 3rd power. Again, this is 1/5 x to the 5th, and when we multiply, we'll just get x to the 4th. We're not looking for where this is equal to 0. We want to know where this has a maximum. So we want to know where the derivative of this changes signs from positive to negative. The derivative of this is the second derivative, the derivative of the derivative. And this will be 4x squared minus 4x cubed. And so we need to see where this is equal to 0. I'm going to factor out the 4x squared. So it's 1 minus x. And I can see that my critical values are x equals 0 and x equals 1. And I'm going to make a sign chart here. and see where the derivative of the derivative changes signs from positive to negative. That's all the time on this video.